Hey everyone, let's take a look at a quick mini lecture on simplifying algebraic expressions. So looking at this 4x to the second power, there are a few pieces that we want to identify. Of course, we see the 2, right, written as a superscript. Well, that's known as the exponent. The base, which is the x, is our variable. That variable serves as the base to that exponent. And then that 4, that number, that value, can be a fraction, decimal, or an integer, is known as the coefficient because it's in front of a variable. So let's take a look at our examples. Our first example, 8c to the second. Our 8 is the coefficient because it's in front of the variable. Our variable is the c, and our exponent is a 2. It's raised to the second power. Next is 9x. Our 9 is the coefficient. Our x is the variable. And for any variable that doesn't show an exponent, there's an implied to be an invisible 1 there. So there's a 1 as the exponent. So 9x is really saying 9x to the first power. We just don't write that 1 all the time, but it's implied to be there. On this third example, y to the 8th, well, we know 8 is the exponent, y is the variable. But also here, the coefficient, there's an invisible 1 there. So if I say y to the 8th power, I can also rewrite it as 1y to the 8th. With that 1 there as the coefficient, there's implied to be an invisible 1 in front of any variable that doesn't have a coefficient already. And then lastly, we have 12, right? And the variables are a and b, and the exponents are 2 and 3. And even that 12 was actually raised to the first power. So we could also write that the exponent, another exponent, is a 1 as well. So 12a squared b to the third. All right, now let's look at what we call like terms. Like terms are terms that have the same variable and are raised to the same exponent. Same variable and raised to the same exponent. All right, terms are separated by plus or minus sign. Terms are separated by a plus or minus sign. So when we simplify using addition or subtraction, we call that combining like terms. Combining like terms. All right, let's take a look at these examples here. Combining like terms. So looking at these expressions, I'm going to look at the first one, 7x plus 5 minus 3x. Terms are separated by a plus or minus sign. So 7x is one term, the 5 is another term, and the negative 3x is a third term. Well, what are the like terms? The 7x and the 3x, negative 3x, right? Because they both have the same variable raised to the first power. So we can combine those. 7x and negative 3x make a 4x. And I'll bring down the plus 5. That's all we can do. We've just now simplified it because we've combined all the like terms possible. The next one, 6w to the second plus 11w plus 8w to the second minus 15w. 6w to the second and 8w to the second are like terms because they have the same variable of w and they're raised to the second power. 11w and negative 15w, they're like terms because they have the same variable of w and they're both raised to the first power. So combine just means to add or subtract depending on the signs. So positive 6w to the second and a positive 8w to the second. There's a 14w to the second. 11w minus 15w. Signs are different, so we subtract and take the sign of the larger magnitude number. So that makes it negative 4w. And then on the last example, we can say, okay, the 6x is a like term with the negative 7x because they have the same variable of x and they're both raised to the first power. And I'll combine those now. 6x and negative 7x, signs are different, so we subtract and take the sign of the larger number. So that makes negative 1x, or I can just write negative x because we know there's an invisible 1 right between the negative sign and the x, right? So you can write negative x or negative 1x. And then all constants are like terms. So the 4 and the 15, positive 4 and positive 15 make a positive 19. All constants are like terms. Constants are any terms that are integers, decimals, or fractions. So we've just combined like terms. Let's go ahead and work with the distributive property a bit here. So the distributive property says when there's a value right outside the parentheses, we go ahead and distribute, meaning multiply. I see the 3 right outside of the parentheses there. And I see a 5 right outside of that set of parentheses. So what we'll do is say 3 times 2x is 6x. 3 times negative 5 is negative 15. Positive 5 times 3x is positive 15x. And positive 5 times positive 6 is positive 30. Next, we combine like terms again. So the 6x and 15x are like terms. Signs are the same, so we'll add them. Keep the same sign. It's 21x. And then the constants, as I just mentioned previously, are like terms. So negative 15 and positive 30. Signs are different, so we subtract and take the sign of the larger magnitude number. So 13 and 15, we subtract them and get 15. The larger magnitude number is the 30, so we take its sign of positive. And we've simplified. So we saw that we had the distributive property, and that made us distribute and then combine like terms. Let's take a look at a few more examples. So 4 times 7x and 4 times negative 8, 6 times 5x and 6 times 10. We get 28x minus, right, positive times negative makes the negative, right? We're not just bringing down the negative. It's a positive 4 times a negative 8. Positive times negative makes a negative 32. And then we're not just bringing down this plus sign, but we say positive 6 times positive 5x is a positive 30x. And positive 6 times positive 10 is positive 60. The like terms are the 28x and the 30x. So that's 58x. And then the negative 32 and the positive 60. The constants are like terms. So that's going to get us 28, and that's positive. And then we'll work on this next one. Same procedure here because we see the 6 right outside of the parentheses, so we can distribute. And the 3 right outside of the parentheses, so we can distribute that as well. So 6 times 4x squared is 20. I'll write it outside of the box because this looks a little bit longer. So this is going to be 24x to the second minus 30x plus 6 times 2. That gets us a 12. And then we have the positive 3 times the negative 8 x to the second makes negative 24 x to the second. All right, and 3 times 11x is positive 33x. And then 3 times positive 4 is positive 12. All right, so now all I want to do is just combine like terms. So here are two like terms, 24x to the second and a negative 24x to the second. Well, they zero out, right? Because one's a positive and one's a negative. So they zero out. The other like terms are the negative 30x and the positive 33x. Signs are different, so we subtract them and take the sign of the larger magnitude number. So it becomes positive 3x. And then we go ahead and combine the constants, right? Because they're like terms as well. One's a positive 12 and the other is also a positive 12. So we go ahead and combine those two, positive 12 and positive 12, give us a positive 24. And that gives us our final simplified expression of 3x plus 24.